Hey everyone, welcome to Programming Bitcoin. My name is Nate Murray and I'm from fullstack.io. And today we're going to set up a private Bitcoin network, and then we're going to create a few transactions within this network. The idea behind using a testnet is so we can have an alternative blockchain that we can use for testing. So our testnet coins, they're totally separate from actual Bitcoins, and they don't have any value. There's actually an official testnet. Testnet 3 actually, that's used by Bitcoin at large. And this is really useful if you want to play around with Bitcoin features on a larger network. And the official testnet, it differs from the normal network in two important ways. One, it has a totally different Genesis block, so it doesn't share a blockchain with the main Bitcoin network at all. And two, the is standard check is turned off. So you can experiment with non-standard transactions, and I'll talk more about these in a future video. Funny story about the testnet actually. Because Bitcoin development depends so much on a test network to try out new things, the testnet started to be thought of as like a stable, valuable altcoin. And people were mining it heavily and trading it for real money and so on. And so the Bitcoin devs, they actually have had to reset the testnet twice. That's why the current testnet is testnet 3. Another thing about testnet 3 is the blockchain is big in its own right. I mean, I think it's over a gig already. So instead of messing around with the official testnet, what we're going to do is we're going to set up our own totally private Bitcoin network. And we're going to use a VM on our own machine to do that. And I'll show you how to do that. For the VM, we're going to use Docker. It's a really awesome way to have a lightweight virtual machine within your computer. I'm not going to cover how to install Docker here. If you don't have Docker installed already, it's totally worth it. It's really awesome. It's all free. So get Docker installed on your computer, and once you have Docker installed, come back here. So we're going to be using a Docker box created by Sean Levine, who goes by the handle freewil. And he has a repo, the bitcoin-testnet-box. And this is what we're going to be using for setting up our testnet. You can take a look at what it's doing by just looking at the Docker file. It's pretty straightforward, just installing some packages, and then we're cloning his version of Bitcoin. And he actually maintains a branch of Bitcoin that he calls Easy Mining. And the idea here is on the Easy Mining branch, the difficulty is set really low, so you can mine blocks a lot faster. So flip over to a terminal and make sure that you have Docker installed. Try Docker info. And what you'll need to do is you want to pull down freewil's box. So you'll do Docker pull freewil bitcoin testnet box. If you need help anytime, you can use Docker help. What we're going to do next is run this container. So to look at the command line options, let's do Docker help run. So we'll call Docker run -t -I, we want to be interactive. Let's call this Docker container bitcoin-d. We'll use the capital P flag, and this says we want to forward the ports automatically that are specified in the Docker file. And then we want to add one more port. We're going to say 49020 map to port 19,000. freewil / bitcoin testnet box. There we go. Our box is already started. So one thing that I want to point out is I've set up this Docker instance to be able to map port 49,020 on my box. When I installed Docker, I allowed Docker to remap these ports. And so this number is the port on my host machine, and this is the port on the container machine. We're going to be using these ports a little bit later on when we want to connect to our testnet from our host machine. So on our host machine, open up a new tab and do Docker ps, and here you can see our testnet box is running. This is our container ID. We named it bitcoin-d, and then you can see the ports here that we mapped. So we specified this one on the command line, and then these two were specified in the Docker file. So flip back over to our container, we can ls, and you can see that there's a few directories here. There's the Docker file that was used to create this container. the make file, which contains some helpful commands, and then a 1 and a 2 directory. Let's cat the make file. And in this make file, you can see we've got a few commands like starting bitcoin-d. And this container, it will boot 2 instances of bitcoin-d, and it will use the datadir 1 and datadir 2. So these directories, directory 1 and directory 2, they each basically contain the data required to run a Bitcoin node, right? So it's got its own wallet, it's got its own copy of the blockchain. And so we can call make start, and it will boot 2 Bitcoin daemons, and they'll connect to each other. So let's do that now. Make start. So there we go. You can see we have 2 Bitcoin servers starting. And if we call make get info, what that'll do is that'll send the get info command, and we can see and make sure that they're connected to each other. So let's say make get info, and it calls out to the first bitcoin-d saying bitcoin-d with the datadir equals 1 get info, and you can see it has 1 connection, the number of blocks, and the second one, same. This image, this container, it already has some blocks pre-mined. You can see here that the number of blocks is 56,101. This is great. It means we already have some coins that we can play with. So let's take a little bit closer look at the configurations, right? So on the first bitcoin-d, we're looking at datadir equals 1. So we can ls1. You can see we have a bitcoin-conf and the testnet3 directory. So let's ls1/testnet3, and here you can see we've got the chain state, some logs, everything that you need, the wallets. If we cat 1 bitcoin.conf, you can see the configuration here, right? We're saying use the testnet, don't use DNS, listen on these ports, and here's RPC username and password. You can find the full list of documentation on the Bitcoin wiki. If we look at the configuration on number 2, one thing that you'll see it's a little different on number 2 is that we're setting listen to 0, so we're not going to listen for any connections from this node. And we're going to connect to 127.0.0.1, port 19,000. So this is saying connect, for node number 2, connect to node number 1. So that's how they're connected to each other. Also take a closer look at the ports. Notice on server 1 that we're saying expose port 19,000. Expose this port on 19,000. So the port option is for the peer-to-peer network. Expose the peer-to-peer network on port 19,000. And RPC port, the RPC port is where we send commands, right? So we send commands over RPC to our local Bitcoin daemon, and then it sends out transactions or messages out to the P2P network. And so RPC port is where we send commands, and port is where the P2P network connects to. So what we have here is a 2-node private testnet. The second node is connected to the first node. So now that we actually have these 2 nodes set up, how do we actually use it? What I'd like to be able to do is open up Bitcoin Qt on my host machine and connect it to my test network. And then I want to be able to send Bitcoins from the wallets here in the container over to the wallet on my host computer. And so the first thing that we need to do is actually prove that we can make a connection from our host machine to the container network. So let's do this. Let's kill our primary Bitcoin-d server, and let's restart it with debugging on the networking on. And let's make sure that we can see the connections being created in our logs. So to do this, we're going to type bitcoin-d datadir equals 1 stop. And let's tail the logs for the first Bitcoin-d. And let's start it back up again. Bitcoin-d datadir equals 1 debug net, and set it as a daemon. And there we go. We can see we've got our log messages tailing through. We can type make get info, And notice something here that when we called make get info, now we saw in our logs this thread RPC server method equals get info. This is coming from tailing the log, and this is coming from the result of our commands. So let's try to send a packet of data to our Bitcoin D from our host. So flip over to your host machine. And I have netcat installed. I'm going to try to use that. I'm going to type echo hello, pipe that to netcat at localhost port 49020. You can see that right here. We mapped 49020 to port 19,000, which is the peer-to-peer port. And what we want to do is, send just any packets at all to the daemon on the container machine. I just want to make sure that the networking is working like I would expect between my host machine and my container machine. So here I'm going to do Command K and clear this screen, and then I'm going to send that packet over netcat and see what happens. So flip back over here, we can see, okay, accepted connection, socket closed, disconnecting node. Let's try it again, and we can see we get that again. So what that tells me is that I can send a message from my host machine over here into the container machine over here. You might have to play with this on your own machine, right? Maybe you need to specify, instead of localhost, maybe you need to specify 127.0.0.1. You might have to play with that. Maybe you don't have port 49020 allowed by your Docker instance. You might have to play with that. But essentially, I'm just trying to verify that I can make a connection between these two machines. You could also try telnet, right? Telnet localhost 49020. Yeah, and for whatever reason, that didn't work right now. So now that we can connect to our test network, let's try to connect to it with bitcoin-qt. On my Mac, I have bitcoin-qt under Applications, bitcoin-qt. So I can actually call this from the command line by typing /applications bitcoin-qt contents Mac OS bitcoin-qt, and I can do --help. And this is how you can pass flags to it. Here I've got a directory where I can store temporary files, and I actually want to make a custom datadir. I don't want to mess up my real Bitcoin wallet. So I'm going to make a new directory here, and I'm going to call it localnet. And when I call bitcoin-qt, I'm going to pass a few flags. I want to say first that we're going to work off of a testnet, and I don't want it to look up other blocks by DNS. Actually, I want to connect directly to localhost port 49020, and I'm going to use a datadir of the current directory localnet. And we'll open up bitcoin-qt. And it says synchronizing with the network. Now, if you get, for instance, if it says no source available, you can do a few things. I mean, check the logs on your container, make sure that you actually did get a connection over here. If you can go up to help and go to the debug window in the menu, and there's debug log file. Open that log up. And check what the messages say in there. If your logs say connection refused, maybe you have some sort of networking issue. Try different variations on your container. Depending on your machine, you might have to try localhost or 0.0.0 or the 127.0.0.1 address, and so on. So if you have everything right, you'll see it saying synchronizing network. Now our bitcoin-qt, you can see that it has it estimates the total number of blocks in the network is 28,050. We can verify that number, flip back over to the container, and there's a lot of logs here, So I'm actually going to Control-C tailing the logs. And we'll do make get info. And you can see here on our testnet, we've got 56,101 blocks. So our Bitcoin QT doesn't actually have all of the blocks ready. So once it reaches this number, you'll see that it starts to increase. And basically what we just need to do now is wait for all the blocks to download. All right, there we go. We've made it all the way up to 56,101 blocks. So now that we're caught up on the local net, we can start sending ourselves coins. First, we want to create an address where we're going to receive coins on Bitcoin QT. So click on Receive, and let's add a label. And you can see we've got our address right here. Now flip over to your container. And we're going to be using the bitcoin-d interface to the RPC commands. So we want to use the configuration in the first bitcoin-d daemon. So with every command, we're going to use the -datadir = 1 flag. So we can get a list of all the possible commands by doing bitcoin-d-datadir = 1 help. We can pipe that to more. And you can get help for any individual command as well. So we can do help, say, list accounts. So let's list all of our accounts and our balances. List accounts. And you can see we have 5,558 in the default account, and in the P2P pool, we've got 3,350. So let's look at all the addresses in the default account. Say get addresses by account, and look at P2 pool. There's an address there. And so now we can actually send some coins to our Bitcoin QT wallet, and we're going to use send from. So help send from. So flip back over to Bitcoin QT, hit copy address, and we'll do bitcoin-d-datadir = 1, send from, and we're going to send from, notice that the send from, the first argument is the from account. So the send from the default account, and we're going to paste our to address, and let's send 42 coins. And you can see that right away, we've already got the 42 coins here in our Bitcoin QT wallet. What was returned here in our container is the transaction ID. So we can get more information about this transaction ID. Let's do get raw transaction, and we'll paste the transaction ID. And here, this is a hex encoded of the JSON of the transaction. So we want to decode it, and we'll use the command decode raw transaction. And you can see we get this big JSON blob here. So we've got the transaction ID, we've got the input transaction, which is this one right here, and the outputs. So you can see we've got outputs, 42 Bitcoins. This is where we sent to our address in the Bitcoin QT wallet. But then we also have this other output of 8 coins. Well, why do we have that? Well, this is for the change address. 42 plus 8, that'd be 50 coins, which is the reward for a Coinbase transaction. Because this is an old, this is a young blockchain, so the reward would have been 50 coins at this time. So we have to send the 8 coins for the change back to our address. But this isn't the address of either of but we didn't see this address in either of our accounts. And so we can actually make sure that this address is our address by copying it, and we'll type bitcoin-d datadir equals 1 list address groupings. And I'm going to use my search, and we can see here, oh yes, this is my address, and it does have 8 coins right now. We can also double check to make sure that we have the right amount in general by doing bitcoin-d list accounts. And you can see that we have the same amount of coins as before, just minus 42. So if you look back here at bitcoin-qt, you can see that we still say wallet out of sync, transactions out of sync, synchronizing with the network. If we look at the transaction and double click on it, you can see that it has 0 confirmed blocks. So what's happening here? Well, we didn't actually start any miners on our testnet. So if you flip over to the container, we can start mining on our container by doing this. Cat the makefile. And there's a handy command here, set generate true. So we'll do make generate true. And let's look at the logs. And let's watch it. Here you can see it says Bitcoin miner, proof of work found, generated 50 new coins, process block accepted. And if we wait here for a minute, it'll generate several blocks. So as this is running, let's do make get info. And you can see the block height is 56,105. Great, so the block height is increasing. Let's flip back over to bitcoin-qt and see what's going on there. Well, it still says the estimated total blocks is 56,101. It doesn't seem to be increasing. Why is that? Well, if we look at the log file, it says check proof of work, n bits below minimum work, proof of work failed, check block failed. See, our bitcoin-qt isn't accepting these transactions because the difficulty is too low. So if you recall, we're using freewil's branch of Bitcoin that has a much lower difficulty for proof of work. So our bitcoin-qt wasn't built with these settings, so it's not accepting the blocks. So at this point, we have a couple of options. One, you can connect to the testnet with a miner that will validate the transactions with a standard level of difficulty, and then bitcoin-qt will accept them. Or you can recompile a test version of bitcoin-qt that will accept these transactions. Either option isn't very hard, but in any case, I'm not really concerned about double spend attacks because I'm the only person on this network. All right, well, that's all we have time for today. My name is Nate Murray, and if you like this video, subscribe to our channel. Cheers.